Hey guys, Mr. T here, just doing another video on the idea of direct proportion. So two variables are in direct proportion to each other if multiplying one of them by a number results in the other variable being multiplied by the same exact number. You can indicate two quantities, x and y, are directly proportional by writing y. And you've got this weird looking A, sort of twisty A shape here that represents direct proportionality, and then x. So given this knowledge that if I multiply one of the variables by a certain number, the other variable will be multiplied by the same number, then in that case y will always be k times by x, where k is the proportionality constant, which is the fancy name for the same number that both variables are multiplied by. Now, you can graph directly proportional variables on a set of x and y axis. And when you do that, you're going to observe two things. The line's going to pass through the origin, 0, 0, in the very corner in the bottom left. And the gradient or slope of the line is going to be whatever k, or the proportionality constant, is. So let's run an example for this. Buns are sold for 60 cents each. Assume x is the number of buns and y is the cost in dollars total. Draw a table of values and use it to show y is directly proportional to x. So let's do a table of values for the x numbers and the y numbers. Let's just do that many. So I could sell 0 buns, I could sell 1, I could sell 2, 3, 4, or 5. If I sell 0 buns, then I'm not going to make any money, or if I buy 0 buns, it's going to cost nothing. If I buy 1 bun, it's going to be 0.6. If I buy 2 buns, it's going to be 1.2. If I buy 3 buns, it's going to be 1.8. If I buy 4 buns, it's going to be 2.4. And 5 buns, 3.0. So if we look at this table of values, you're going to notice a pattern here. When x is multiplied by 2, 1 times by 2, what do you notice has happened with y? 0.6 times by 2 gives you 1.2. So both the x and the y were multiplied by the same number. So that suggests direct proportionality. But we can't be sure unless it's always multiplied by the same number. So if we move across, the next one, 1 times by 3 gives you 3, and 0.6 times by 3 gives you 1.8. The rest I won't write, but hopefully you can see it. 1 times by 4 gives you 4, and 0.6 times by 4 gives you 2.4. So multiplied by both of the variables by the same number again. And then 1 times by 5 gives you 0.6. 1 times by 5 gives you 5, and then 0.6 times by 5 gives you 3. So x and y always multiplied by same number to give corresponding values. So y is directly proportional to x. That's A done. B, draw a graph of buns bought versus total cost and use it to show y is directly proportional to x. So this might take a while because drawing straight lines on here is not very good. This one. It's the other, origin, arrows. This is going to be the cost. This is going to be number of buns. So we sold 0, sold 1, 2, 3, 4, 5. And then let's do the cost of 1, 2, and that's a bit too close. I think we go 1 as 4. 1, 2, $3 up there, so it's going to be easier to graph. So when I sold 0 buns, made 0 money, or if I bought 0 buns, it cost 0. If I bought 1 bun, then it costs 0.6, so 0.5 is here, 0.6 is going to be around here. 2 buns, 1.2. 3 buns, 1.8. Further down. 4 buns, 2.4. 5 buns, 3. Alright, so you can see that forms a straight line, just a little wonky because of my inaccuracy on the screen. So we said previously that when directly proportional variables are graphed, there's 2 observations. The line passes through 0, 0, and the gradient of the slope of the line is k. So what we can see here with k is you've gone across by 1 and you've gone up by 0.6. You've gone across by 1 and 0.6 up to 1.2. That's also 0.6. So k must be 0.6, and it passes through 0, 0, so therefore y is directly proportional to x. C, state the law connecting x and y. Well, that's pretty clear now because we worked out what k is. C, y is equal to k times by x. Y is equal to 0.6 x. And then D, use the law connecting x and y to find the number of buns sold if $750 was spent on buns. So this shows you the usefulness of this law, because obviously I don't have space and it was difficult enough already to draw an accurate graph for 5 buns and $3 spent. This is asking how many buns were bought or sold when I spent $750. So instead of drawing all that, I can use the law. Y dollars is equal to 0.6x, where x is the number of buns sold. Now I know it was $750 spent, 0.6x. What's 0.6 doing to x? It's timesing. What's the opposite of timesing by 0.6? Dividing. So divide both sides by 0.6. That cancels down to 1. 750 divided by 0.6 gives you 1250 is equal to x. So 1250 buns for $750. Okay? So hopefully that helps you out with direct proportion, and I'll see you in the next video.